Okay. Hello everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S Exam Prep. So guys, after the yesterday's discussion that why do we need database management system, we are actually going to move toward the real understanding of database management system. In the today's session, we will discuss a very basic concept that what are the different types of keys in relational database management system. So we will also understand that what is the relational database management system. We will also understand the different terminologies associated with relational database management system. Then we will move to the different types of keys. We will also see that why keys are important. Okay. So this is brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience. These are the achievements and area of expertise. Okay, so there is an announcement for all of you that BYJU'S Exam Prep team is coming up with a BYJU'S Premier League series. This series will be YouTube plus app based series. So we will discuss some concept on the YouTube, and then we will ask you to participate in the quizzes, and those quizzes will be taken at the BYJU'S Exam Prep app. So you just need to register for that. Those are absolutely free. So you just need to register on the app and you need to participate in the quizzes so that you can actually understand that whether you are able to apply the concept learned in the YouTube on the actual questions or not. So this is all about BYJU'S Exam Prep League. Now let's move ahead with the topic. So the very first thing is that we are talking about various types of keys in relational database management system. But first try to understand that what is relational database management system. Okay, so first we need to see that what is RDBMS. So very basic definition, I'll keep it simple. So what is this? RDBMS are based on relational model. So RDBMS is a management system which is based on relational model. So there are various type of models: hierarchical model, relational model, right? So various, right? So there are various type of models based on which, or networking model, right? So that's the idea. But this RDBMS is purely based on relational model. So who is the one who defined the term relational model? It is basically defined by Dr. Edgar F. Codd. So whatever you see in the relational database management system is eventually defined by most of it, Samantha, most of it, right? So so see, there are multiple series. So initially I'll complete the normalization in this series, then 24th onwards I'm also having a series which is BYJU'S Premier League concept series. In that particular series I'll discuss the concept of query languages. So I'll complete the query language portion there. So don't think that all the things will be in a same series, but under the umbrella of BYJU'S Exam Prep, we are going to get everything. Okay, so that's the idea, Samantha. So let's move ahead. So this is given by E.F. Codd. Now, what did he say? That everything about the database should be represented in the form of table, which is also known as relation. So in relational model, we model the data. So how do we represent the data? We represent the data in the form of relation, which is also known as table of the relation. Now, so let's see, there are many things. So we also define the ER model, entity relationship model. So that we will see after a while, because the questions from that particular topic are asked very rarely. Also, even if you get a question from that particular field, you will get 1 mark theoretical question, or the question will be based on the concept of relationship between the different tables, so that you will be able to understand in a better way after discussing the concept of relational database management system. Therefore, I have started with this particular thing. So generally, if you think in a book, you will understand the concept of ER model. You will read a lot of theory related to ER model. Then you will come to the relational database management system. But we have already studied something about ER model in the college level. Therefore, we are not going to waste that time in discussing that theory and starting with the RDBMS. So we are directly starting with RDBMS. So a relational database consists of what? Collection of tables. So let's assume that there is a database in which you have the information about a student. That's one entity. if you think in terms of ER model. So student is one entity, course is another entity. Now, how student and course are related? Are they related? Yes, sir. Students will eventually enroll for the courses. I hope you understand that. What do I mean by relational database management system? There will be multiple tables, but they are all related with each other. Somehow they are useful to retrieve the information from one table based on the information available in the another table. So that's the idea, that we will represent everything in the form of tables. So there will be a separate table for a student, there will be a separate table for course. Now, how they are related? They are related using the relation enroll, that student will eventually enroll for the course. So you will have another table which will be for enroll table, that how one entity, that is a student, is related to the another entity, that is course. That's what is defined by the entity relationship diagram, and that's what we will understand, that how that entity relationship diagram can be converted into relational database management system. So okay, so that's the idea, that everything will be under the related collection of tables. So why do I say collection of tables? Because there are different entities which are individual entities, but somehow they are related, right? So we'll have the tables of individual entities, and we will also have the table of relation, that how they are related, right? So which are related with each other. Obviously, each table of a relational database should have a unique name. In the same database, you cannot have two tables with the name student. Not allowed. If you define one student and if you try to define another database which is with the name student, then you will get an error that the student database already exists, right? So you cannot have two tables of the same name. So every table should have a unique name. That's it. So that's RDBMS, that everything is available in the form of tables, and those tables are related with each other. So you will also have the tables or the relation, that how one entity is related with another entity. So let's see. Okay, so we have understood the relational database management system, that what the relational database management system is. So now let's try to understand the terminologies which are useful for the relational database management system. So the very first terminology is table, that I am saying table. So everybody knows what is a table. Table is nothing but a collection of rows and columns. So you can actually see that there is a table, a student. Now, what you need to learn is that this student actually represent an entity type. If you think in terms of ER diagram, that this is the entity type. Each entity, it is the entity type. Now, what are the entities? Every row of this table will represent entities. So this is one entity. This is one entity. Right, so every row will represent one entity. So the student table is the entity type. Entity type will have attributes. So what are this? These are known as attributes of that entity, which will be used to define that particular entity, that okay, you can eventually uniquely identify a particular entity if you know about following attributes, right? So these are the attributes. Sorry guys. Also known as fields of the relation. Attributes also known as fields of the relation. So that's it. So you will have an entity type. For that you will have different attributes which will differentiate one entity from another entity. So a student is a type of entity. Now this is a student S1. This is a student S2. How do you differentiate one student from another student, or how do you get the information about a particular entity is based on this attributes. Clear? So this is the thing related to a simple concept, which is a table. So table will eventually correspond to the entity or the relationship between two entities. ER diagram. What is this? Entity relationship. ER. Entity. So you will have the tables for entities as well, and you will also have the tables with corresponding to the relation, that how one entity is connected with another or related with other entities of the table. So that's it. Simple. I hope everything. If you have any doubt, please ask me. Okay. Now, the next thing which you can define in the RDBMS is the degree or arity of the relation. Degree or arity of the relation. So how did we define? The number of attributes or fields or columns in the relation is defined as arity, an array. So it's a 3-array relation. This is basically a 3-array relation. 3 arity is 3-array relation. If there are 4 attributes, it's a 4-array relation. M array relation, M attributes, right? So arity. or degree. Degree is also the same thing, that how many attributes or fields are present in the relation. So what will be the degree of this relation? Degree of this relation will be 3 because it consists of 3 attributes. Simple. Clear. So these are the important things. Next is tuple. So what do you mean by tuple or record? So each row of your table, will represent one tuple. So this is tuple 1. This is tuple 2 and so on. So each row of the table will define a tuple or record of that particular table. So that's again tuple or record. So there are 4 tuples. There are 3 attributes. Therefore, the degree of the table is 3. So if there are 4 tuples, then do we define based on the number of tuples? Yes, that is known as cardinality. What do we call it? Cardinality. The total number of records or tuples in a relational table is defined as cardinality of that relation. So what is the cardinality of this relation? Sir, cardinality of this relation is 4. Okay, so we have understood 4 things. Table, we understood. Degree, we understood. Tuple, we understood. Cardinality. Next, relational schema. So, sir, this is a relation. This is a relation, a student table with roll number, name, branch and all other information. This is a relation. What is relational schema? So, relational schema represents the abstract view of the relation. What does it represent? It does not represent the complete detail about the relation, but it gives you the abstract view of the relation. What does it mean? Example, if I give the example, then you know that there is a table with a name student which consists of 3 attributes: roll number, name and branch. Therefore, you will have a relational schema. You will denote it like you will have a student. So this is the name of the relation or the name of the table, and inside this brackets you will define the different attributes of this particular relation. So first attribute is roll number, name and branch. So if somebody gives you only this much information that this is the relational schema, if only this much information is available that this is the relational schema, then what do you know? You will know one thing, that okay, in the database there will be a table whose name is student, and that particular table consists of 3 different fields or attributes. One attribute is known as roll number, another attribute is name, and the third attribute is branch. So you will have the idea that what type of that table is in the database. You may not know the internal values. That what are the values available in that particular relation, but you will have an idea that okay, the structure will be something like this, that these are the information which I can gather from this table is student. Okay, so relational schema. Then comes relational instance. What is relational instance? So let's try to understand the definition carefully, because instance is something which generally confuse people, that they try to define the keys of the relation based on the instances, right? So what's the idea? The set of tuples of a relation at a particular instance. So at this point of time, these are the tuples. So the set of all these tuples which is presently there in this particular relation will be called as relational instance of this particular time. This relational instance may change with the time. If somebody performs a insertion operation, a new item is inserted, so instance will change, the number of or the overall set will change. Deletion, if you have deleted something, the size of set will reduce. If you have added something, the size of set will increase. If you update something, let's say tomorrow, if a student with roll number 4 decides that no, I don't want to be a part of computer science branch, but I want to change my branch to IT, would be a wrong decision. But still, if the student 3 wants to change its branch from computer science to IT, then what will happen? If the student changes his branch, then the relational instance is changed, because the value, this is one element of the set of tuples. Previously, this element had the value CS. Now, if you change the value of particular field branch, then this tuple has changed. So if it has changed, then the element of the set of tuples is also changed. What subject teach in bad batches? From 30th of June, I guess I am starting with compiler design. So the very first subject I'll deal with is compiler design. So from 30th of June, you will come to know about the exact date. But from 30th of June, I believe I'll be starting with the compiler design as per the information which is available to me. Okay, so it can change with insertion, deletion or update operations. So I hope you understand. So don't try to define the concept of keys based on this instance. So let's try to understand. I'll explain when the time comes that how you should not define the concept of keys based on the instance, but this is it. So I hope you have understood all the definitions. You have understood the concept of relations, the representation in the form of table. You have understood the concept of attribute. That attribute eventually will define the different elements of an entity, that how you can eventually learn more about that particular entity, right? Then degrees, then tuples, then cardinality, then relation schema, then relational instance, and so on. Now comes the chords rule. So when Mr. Edgar Cord done with the research of relational database management system, they eventually defined that there are 12 rules which our database must obey in order to be regarded as a relational database. So if you want to call our database a relational database, then this 12 rules of Mr. Cord must be obeyed. I am not going to discuss all about these rules. I am just going to give you the intuition of one particular rule. So because these are not important from the GATE point of view, somebody may ask you that which of the following is the rule given by Edgar F. Cord, but that's not important from your point of view. So what's the idea? Edgar F. Cord defined 12 rules. One of the rule is guaranteed access rule. What does it say? The guaranteed access rule defines that every single data element should be guaranteed to be accessible logically, accessible logically with a combination of what? With a combination of table name. Let's say if I give you the name, that the table name is a student. So if you give me the table name, that is a student. If you give me the information about the primary key, that okay, let's assume roll number is the primary key, then you are giving that this is the particular primary key, and you don't want to see the complete record of that particular roll number. Let's assume that you are looking for the branch of the student whose roll number is 4. Then you should have the information about the table name, that is a student. You should have the information about primary key, that what is the key based on which you will access the table. So the primary key is roll number. So you have the information of roll number, that is okay. And you have the information about the attribute, that okay, I want to access this particular attribute, or I only want to access the tuples in which the value of this particular attribute is this, or follow this particular condition. What the idea? So this is the idea, that you must be able to access every single element of the table based on these three things only: table name, primary key, and attribute name. So from here comes the concept of primary key. I hope this is not visible, so let me move aside a little bit if you guys can read. It's very bad of me to have this the data in this particular segment of slide, but sorry for that. Okay, so let's move. So that's the idea. So basically what is defined by the Cord, Mr. Cord actually defined with the help of this rule that every relation should have a key. Every relation should have a key. So from here we come to know that okay, something is needed based on which we can actually access the information from the database, right? So that will be needed. Now comes the different types of keys, that okay, we have learned that okay, keys are needed, but what are the different types of keys which may be present in the system? So the very first type of key is candidate key. This is most important. This is most important. See, not from the actual database implementation point of view, but from the GATE point of view. When it is related to GATE, the questions will be, or the concept will be based on this concept of candidate key. So you just need to understand this. So what is a candidate key? A minimal set of attributes. Let's try to understand this. Minimal has to do with the property that if you remove anything from that particular set, then it loses its property. Getting the idea? Minimal or maximal has nothing to do with the number. Minimal and maximal are related with the property. I have explained in the class of discrete mathematics as well that minimal and maximal are related with the property, not at all related with the number. Don't think that a key with minimum number of elements is a candidate key. No, a set which is minimal, that is, if you remove anything from that set, then it will lose its property, then it is minimal. Okay, so what is the property? Property of uniquely identifying the tuples in the relation or table. What is the property? The property of uniquely identifying the tuples in the relation or table. So that's the idea. So let's assume in this case roll number is a candidate key. In this case roll number is a candidate key. So any attribute whose values are distinct or any attribute whose values are unique will form the candidate key. It will form the candidate key. Now, the idea is there is something called null. So, generally people get confused that null values are allowed in the candidate key set or not. So, null values are allowed in the candidate key. Null values are allowed in the candidate key. So, what does it say? The minimal set of attributes which uniquely identify the tuples in a relation is called candidate key. So minimal. So let's assume, so for this relation, what will be the candidate key? Sir, for this relation, candidate key will be roll number. For this relation, candidate key will be roll number. Now let's think about a different relation. Let's assume if I give you a relation enroll. If I give you a relation enroll in which we have the roll number, we also have the course ID. That's a different table. Course will be a different table. So you also have the information of the course ID. And let's assume that you have the information of branch. What am I trying to suggest here is, see, roll number. So a student S1 can eventually enroll for course C1. Is it possible that one student enroll for more than one course? Is it possible for a student to enroll for more than one course? Yes, sir. I can enroll for database as well as I can enroll for operating system. So yes, so student S1 can also enroll for course C2. Similarly, is it possible that one course is enrolled by multiple students? Yes, sir. Student S2 can also enroll for course C1. Student S2 can also enroll for course C1. Now let's assume, so let's assume that the branch is CS. Here the branch is CS only, and here the branch is IT. It's perfectly possible, right? Now tell me, what will be the candidate key of this relation? What will be the candidate key of this relation if you think at this? So see, sometimes the information will not be available in the form of FDs, but you will have to understand that one student will enroll for one course only once. One student S1 will enroll for course C1 only once, right? Now, student S1 can enroll for another course as well, but S1 can enroll for one course only once. So what's the idea? So the idea is that if you know the information of roll number and you know the information of course ID, then this value that S1 has enrolled for course C1, this value will not appear anywhere else in the table. That S1 has appeared, S1 has enrolled for C1. So that's okay, that S1 has enrolled for C1. So this is good enough that S1 has enrolled for C1. This information need not appear anywhere else in the table. So you know that these two values together, individually the value of roll number may not be unique. Individually the value of course ID may not be unique. But you know that together the value of roll number and course ID will be unique in the table enroll. Yes. So there will be other aspects of looking at this information, but that's okay. Now, let's think of some other relation which is not available in this form, but somebody is saying A, B, C. No information is available about A, B and C. Let's try to understand. No information is available about A, B and C, but you just know the values. 1, 2, 3. 2, 1, 2, 3, 3, 1. Can you give me the candidate key of this relation? Can you give me the candidate key of this relation? Any of the candidate key. Can you give me any of the candidate key for this relation? Let's assume this relation is R. Can you give me the candidate key of this relation? That's something which I want to discuss with you guys. So let's try to understand. Here we have the information that roll number and course ID are part of this table enroll. So one student will enroll for one course only once. One student will enroll for one course only once. So we can gather some information based on the name of these attributes and the name of the relation. But here we don't know what is A. We don't know what is B. We don't know what is C. So you may say, sir, the values of A are unique. You may say that values of A are unique. So you may say, sir, the candidate key is A. You may say, sir, the candidate key is A. But the idea is, let's try to understand this. The idea is that this is just an instance of this relation R. This is just an instance of this relation R. Perhaps possible that after a time a value is inserted in this table which is something like 314. A value is inserted which is 314. Now for when A is 3, the value of B and C are 2 and 1 with respect to this particular tuple. But with respect to this new tuple, when A is equals to 3, value of B and C are 1 and 4 respectively. That means based on this value of attribute A, you cannot uniquely identify that which tuple you are talking about. Based on the value of this attribute A, you cannot uniquely identify that which tuple we are talking about, because this 3 may be corresponding to this tuple or this 3 may be corresponding to this tuple. So if based on an attribute you cannot uniquely determine that which tuple you are talking about, then it is not a key, right? Because the definition of key suggests that a set of attributes which can uniquely determine all the tuples, uniquely identify all the tuples of a relation will be called a key. But here there is a problem that this cannot be defined as a key. So based on the instance, you may see that the values of A are distinct. Therefore, we will not define, learn it and understand this. We will not define the concept of candidate key, or we will not define the keys based on the instance. Keys are not defined based on relational instance. Then what we will see in the next session, that keys are defined based on functional dependencies. We'll see that what is the dependency of one attribute or another attribute. So that's it, right? So that's the information which you need to understand, that okay, keys will not be defined based on the relational instance. Keys will be defined based on the functional dependencies. So if somebody tells you that if this is the relational instance, then can you define the candidate key of this relation? You will say perhaps it may be, but yes, you can define one thing. You can define one thing. If the values of B are duplicated, then you can define at least one thing, that which among the following attribute is not a candidate key, or which attribute set is not a candidate key. You can at least define that much, that which candidate key, which attribute set is not a candidate key. Because if the value is being repeated and for whenever B is 2, the values of A are different, therefore B cannot be the candidate key. Therefore, B cannot be the candidate key. So, inverse you can define that if the values are duplicated in the relational instance, that particular attribute or attribute set cannot be the candidate key. But in a relational instance, if the values are unique, then it does not mean that that is a candidate key. It may, relational instance may change over the time. So we don't know, right? So just to understand the concept of key will completely depend on the concept of functional dependency, that what attributes together will form the candidate key. So it is minimal. So if you remove roll number from this set, then course ID alone cannot uniquely differentiate the tuple, because for this C1 the tuple may be S1 C1 CS, and for C1 it may be S2 C1 CS. So you will not be able to uniquely determine that which tuple you are talking about. Similarly, if you remove this tuple course ID from this set, then roll number alone will not be able to define that which tuple we are talking about, because for S1 it is S1 C1 CS, and for S1 it is S1 C2 CS. Then we cannot uniquely determine, or we cannot uniquely identify that which tuple we are talking about. Therefore, if we remove roll number, then course ID alone cannot form a candidate key. If we remove course ID, then roll number alone cannot form the candidate key. But these two values together can form the candidate key. So this set is minimal set. Why? Because if we remove anything, or if we remove any attribute from this set, then it will lose its property to uniquely identifying the tuple. Yes or no? No, FDs are not defined based on instances. FDs are not defined based on the instances. FDs are defined based on the knowledge of the database. You know that, okay, roll number and course ID. So you can eventually define, there will be a FD in the FD set with respect to this relation, in which we will say roll number and course ID can determine branch. That's something like that. So if you know that roll number and course ID, then you will have a unique branch, right? So that's the idea, that you will not define the instances, you will not define the FDs based on the instances. That's basically, the FDs are defined by the database designer. He will have the complete knowledge about the attributes of a particular entity, that this entity is used for this purpose, this entity can give me the information of this other thing, this particular attribute can give me the information of this other attribute of this particular entity, and so on. So don't think that FDs will be defined based on the instances. No, not at all. Clear? So I hope you have understood one thing, that candidate key is a very simple definition, that the minimal set of attributes which can uniquely identify the tuples in a relation will be called candidate key. Simple definition. Don't need to worry about. So there may be multiple candidate keys. So that's the note we can which we can note down. There may be more than one candidate keys. There may be more than one candidate keys in a relation. Yeah, obviously possible. Multiple attribute sets which are minimal and can define or can uniquely identify the tuples of the relation. So that's okay, that there are multiple, that's fine, right? So this is it. So what did I say? Null values are allowed. Null values are allowed in the candidate key. It is a minimal set, and so on, right? So once you have understood the definition of candidate key, now give a term which is known as primary key. Primary key. So what is this primary key? There are many candidate keys. You will choose one of the candidate keys and you will define the candidate key as a primary key, that from now on you are the primary key. I will search into the table based on you. From now on, you are the primary key. So that will be the concept of primary key. There may be more than one candidate key. So you will choose one out of many candidate key. And you will define it as primary key. Fine. So that's okay. But the idea is primary key in candidate key. Candidate key attributes are allowed to take the null values, but primary key attributes are not allowed to take null values. Now, when we say every relation should have exactly one primary key, then it means there should be at least one candidate key whose attributes are not allowed to take null values. Otherwise, you will not be able to define the primary key. So, you can actually say there should be at least one candidate key there should be at least one candidate key in which attributes are not allowed to take null values. So these are the constraints which will be defined when you define the database, that okay, student, so roll number is not allowed to take a null value. There cannot be any student whose roll number is not given by this college or school, right? So that's the idea, that you will have the information about the attributes, and you will know that okay, this attribute is never going to take the null value. But you can say, sir, passport number. So you can also have, let's assume that passport number is a mandatory thing, so it's a different thing. But let's assume if somebody does not have a passport, then it is also possible that someone is not having a passport. So there may be a student who is not having a passport. So passport number will be unique. Passport number will be unique in the table. If I also define one column with respect to passport number of every student, then okay, the passport number values will also be unique. But there may be some students who are not having a passport. So for them, passport number field will be null. And if the null value is present, then it cannot form a primary key. Yes, passport number can eventually form a candidate key. Passport number can eventually become a candidate key, but it will not be able to become a primary key because it can eventually take null values, right? So that's the idea, that you will have the prior knowledge of the database. Whosoever is creating the database will have the prior knowledge of the database, and based on that, it will define that which particular attribute is not allowed to take null values or will not take null values. So it will eventually define unique and not null. So it will become a primary key. You can also define these two things together will become a primary key, right? Okay. So again, what is another key? So another key is alternate key. So what did I say? There are many. There may be more than one candidate key. There may be more than one candidate key. So you will choose one out of multiple candidate key as a primary key, and the leftover candidate keys will be called alternate key. So candidate keys except primary key. So we'll define one candidate key as primary key. The leftover will become alternate key. The leftover will become alternate key. Simple. Now what's a super key? So the definition of, let's try to understand the definition of a super key. What does it say? Any set of attributes which can uniquely identify the tuples in relation or table is called a super key. So is it not exactly same as candidate key definition? No. What did I say? In the candidate key definition, in the candidate key we define any minimal set. What? A set which will lose its property, a set which will lose its property if some of the attributes are removed from that set, right? Then it is known as minimal. But in the super key definition, any set of attribute which can uniquely differentiate or uniquely identify the tuples in the relation will be called a super key. It need not be minimal. So minimal set is not a constraint for an attribute set to be regarded as super key. So you may have some attribute sets. So let's try to understand. Sir, here. Look at this. Sir, is this roll number and course ID together is a candidate key? Yes, sir, it is a candidate key. But if I ask you one thing, that if I take three attributes together, that is roll number plus course ID plus branch name or branch, right? So if I this three together, then also the combination of this three will also be unique. The combination of this three will also be unique. It is unique. So if it is unique, therefore it is a super key. It is a super key. Now you just need to understand, sir, the combination of candidate key can also uniquely identify the tuple. Yeah, so it is a candidate key as well as a super key. So you just need to understand one thing. Every candidate key is a super key because minimal is not a constraint for super key. Therefore, it may be minimal, it may not be minimal. So if it is a key which is minimal, then it is a candidate key as well as super key. But something which is a key, that is something or some set of attributes which can uniquely identify the tuples in the relation, but that set of attribute is not minimal, that even if you remove branch from this set, then also it can uniquely identify the tuple. If you remove this particular attribute from this set, then also it can uniquely identify the tuples from the relation. Therefore, it is not minimal. So we are saying can be removed. Can be removed. Therefore, not minimal. And if it is not minimal, therefore it cannot be a candidate key. Therefore, not a candidate key. If a set of attribute which is a key but not minimal, then it will not be a candidate key. It will definitely be super key but not a candidate key. Clear? So this is it. So we know primary key concept, alternate key concept. We also know the super key concept. So what's the idea? Sir, okay, let's see. At least one of the subset of super key is also a candidate key. If you have a super key, then there are many subsets for a set. So super key is what? Guys, just 1 minute. Just 1 minute. I didn't connect the charger with the laptop. Just 1 minute. Just give me 1 minute. Sorry guys, sorry. I'm extremely sorry. Sometimes such silly things happens. Okay, anyway, so let's move ahead. At least one of the subset of super key is also a candidate key. You can actually see here. Sir, is this a super key? Did we define roll number, course ID and branch as a super key? There is a subset of this set which consists of the subset. So there are how many subsets of this set? So for this set there are 2 raised to power 3, that is 8 subsets. But at least one of those 8 subsets, if it is a super key, then at least one of those 8 subsets will be a candidate key. So in this case, the subset roll number comma course ID will become a candidate key. Got the idea? So what will be there in the super key? A super key will consist of attributes of at least one candidate key. Super key will consist of attributes of at least one candidate key plus 0 attributes or one or more attributes from the relation. 0 attributes or one or more attributes from the relation. So if I define it here, that super key attribute set will be composed of what? Super key attribute set will be composed of what? Sir, super key attribute set will consist of attributes of any of the candidate key. It will have the attributes of at least one of the candidate key. It will have attributes of any of the candidate key, at least one of the candidate key, plus 0 or more attributes from the relation. So let's assume if I have, so let's look at this. If I have a relation R, with attributes A, B, C, D, E, F. Okay. Now, if I tell you that the candidate key of this relation, if the candidate key of this relation is, let's assume AB is a candidate key and another candidate key is, let's assume CD. Another candidate key is, let's assume CD. Then what will be super key? What will be super key? Super key will be AB plus 0 or more attributes of remaining attributes. 0 or more attributes of remaining, as well as CD plus 0 or more attributes of remaining. Now let's try to understand. These are the only candidate keys. This is one candidate key, this is another candidate key. So in every super key, either AB will be present or CD will be present. Either AB will be present or CD will be present. So along with AB, CD may also be present. Along with CD, AB may also be present. But at least one of these two sets, AB or CD, will be present in every super key. At least one of these two sets, AB or CD, will be present in every candidate key. That's for sure. Right? that, or you can actually say superset of any candidate key. So if you know AB is a candidate key, if you know AB is a candidate key, then what are the supersets of AB with respect to these elements? Sir, AB will be superset of itself. Apart from that, ABC will be superset, ABD will be superset, ABE will be superset, yes, this is D, ABE will be superset, ABF will be superset. Then you can have the combination of these are two, these are the combination of three. You can have the combination, yes, you can have the combination of two. So you can say AB CD is a candidate key, AB CE is a candidate key, AB CF is a candidate key, and so on. So any superset of AB, any superset of AB with respect to these elements, any superset of AB with respect to these elements of the set will be a super key of this relation. Similarly, any superset of CD will also be a super key. So you need to understand there will be some supersets of AB which will also include CD, and there will be some supersets of CD which will also include AB. So you need to make sure that when you are counting the number of super keys, you should not count the same key twice. When you are counting the number of super keys, you should not count the same key twice. Got the idea? So at least one of the subset of super key is also a candidate key. Okay, so that's one thing. So I would like to, before this number of super keys, I also want to inform you about some more things. What? So these are not related to number of keys, but let's try to understand the concept. What attributes belonging to any of the candidate key, attributes belonging to, these are the definitions which you should know, because I'll use these definitions when I'll discuss the concept of normalization. Attributes belonging to any of the candidate key are called prime attributes. What do we call them? Attributes belonging to any of the candidate key are called prime attributes. Right. Now, if a candidate key is formed of a single attribute, so you may have, let's assume that relation R in which the attributes are A, B, C, D, E. So you may have a candidate key which is form of a single attribute, that A is one candidate key, and let's assume CD is another candidate key. So this is a candidate key which is form of a single attribute, then it is called a simple candidate key. A candidate key which is form of two or more attribute is called a composite candidate key, right? So a candidate key which is form of single attribute I should have written this. Single attribute is called simple candidate key. What do you call it? Simple candidate key. A candidate key which is form of two or more attributes is called compound or composite candidate key. It's called compound or composite candidate key. So these are some other things related to the definition of candidate key, that let's assume if A is a candidate key and CD is a candidate key, then what are the prime attributes? Sir, attributes belonging to any of the candidate key. So A belongs to a candidate key, C also belong to a candidate key, and D also belong to a candidate key. Therefore, A, C, D are called prime attributes. These are the prime attributes. Now, once you know the definition of non-prime attribute, you also know what are non-prime attributes. So attributes which are not part of any candidate key, or attributes which are not present in any of the candidate key, will become non-prime attributes. So here B, C, D, E. B and E will become non-prime attributes. So this is the definition of prime attributes, non-prime attributes. So we know attributes, what are the prime attributes, what are the non-prime attributes. This definition will be useful when we will try to understand the concept of normalization. A candidate key which is form of single attribute is a simple candidate key, and a candidate key which is form of two or more attributes will be called compound or composite candidate key. Fine, good enough. Now let us understand some concept related to number of super keys. I'm going to delete this. If you are taking notes, it's fine. Otherwise, when you will watch the session again, you will read this thing again. Anyway, you are not going to get the PDF. So even if I delete it, no harm. Now, let's talk about number of super keys, right? That how many super keys are there in a relation. So let's start with the very basic question. Then we'll try to understand that how the concept can be utilized in generic situation. So let's try to understand this. What is it? Something went wrong? No, all good. Okay. So let me define a problem, and let's see. Let R be a relation with n attributes simple question. Let R be a relation with n attributes A1, A2, A3 up to AN. Right? How many super keys are possible? How many super keys are there of relation N of relation R if first, the only candidate key of relation R is A1. So, if there is only one candidate key and which it is also composed of a single attribute A1, then how many super keys will be possible for relation R? Tell me. How many super keys will be possible for relation R? Sir, this is simple enough. What is a super key? Sir, actually super key is nothing but any of the candidate key attributes. There is only one candidate key, therefore A1 must be present plus 0 or more attributes out of remaining n minus 1. Right? So in how many ways we can do this? In how many ways we can do this, that we can combine 0 or more attributes out of this n minus 1 attributes with A1? Sir, there will be exactly 2 raised power n minus 1 subsets. There will be exactly 2 raised power n minus 1 subsets of this remaining n minus 1 elements. Phi is also included. So you can combine phi also with A1, because phi with A1 will be 0 attributes. Phi with A1 will be 0 attributes. Right? Now, getting the idea? So you can combine, there are 2 raised power n minus 1. So these are the n minus 1 elements. For n minus 1 elements, 2 raised power n minus 1 subsets. Right? Now, each subset is just different from another. Now, you can union those 2 raised power n minus 1 subsets with A1, and after every union, you will get one super key. After every union, you will get one super key. Yes or no? So the only candidate key of the relation R is A1, then 2 raised power n minus 1 super keys are possible. If I ask you a new question, give me the answer this time. The only super key, or the only candidate key of relation R is A1, A2. That is, these two together form a candidate key of the relation. These two attributes together form the candidate key of the relation. Then exactly how many super keys will be there in the relation R? Give me the answer. If you have understood the first concept, now you can give me the answer for the second. This is very easy, I guess, sir. Very easy. What will be the answer, sir? A1 plus A2 must be present. A1 plus A2. So what will be a super key with respect to this yellow color? So A1 plus A2, that is A1 should be present and A2 should also be present, plus 0 or more out of n minus 2. So in how many ways we can union 2 raised power n minus 2 subsets with a set consisting of A1 and A2. So this will be 2 raised power n minus 2. Cool enough. So this is okay, right? So similarly, if out of this n elements, if m elements together form a single candidate key, then number of super keys will be 2 raised power out of n. If m are forming a candidate key, then 2 raised power n minus m super keys will be there. Now let's move to the next question, that how many super keys will be there if the candidate keys, this time there is not a candidate key, there are multiple candidate keys. If the candidate keys of relation are A1 and A2. Number of subsets equals to cardinality of power set. Correct, GTZ. Correct. Give me the answer. The same question, that there is a relation R which consists of n attributes A1, A2, A3 up to An, but this time there are two candidate keys of relation R. One is A1, another is A2. Bolo. How many such super keys? So let me give you an example. So let's assume that these are the candidate keys, these are the super keys in which A1 is present. So how many super keys will be there in which A1 is present? Tell me, how many super keys will be there in which A1 is present? Sir, the number of super keys in which A1 is present will be 2 raised power n minus 1. Right? Similarly, and now let's try to understand these super keys in which A1 is present. I already told you that in some of the super keys A2 will also be present. So let's assume A1, A2, A3 is a super key or not? Sir, A1, A2, A3 is a super key in which A1 is present as well as A2 is also present. Right? So when you are calculating the number of super keys in which A1 is present, then in 2 raised power n minus 1, those super keys are also included in which A2 is also present. Right? Similarly, now if I calculate the number of super keys in which attribute A2 is present, if I calculate the number of super keys in which attribute A2 is present, then there will be exactly 2 raised power n minus 1 such super keys in which A2 is present. Out of those 2 raised power n minus 1, there will be some in which A1 is also present. So these are exactly the super keys in which A1 plus A2 both are present. There are some super keys in which both A1 and A2 are present. So tell me, how many are the super keys in which A1 and A2 both are present? My answer is, how many are the super keys in which A1 and A2 both are present? Sir, you are taking A1 as well as A2, then you can choose remaining n minus 2 elements in 2 raised power n minus 2 ways. You can choose remaining n minus 2 elements along with A1 and A2 in 2 raised power n minus 2 ways. Therefore, the keys in which both A1 and A2, the super keys in which both A1 and A2 are present will be 2 raised power n minus 2. So you are actually looking for the super keys which are composed of either A1 or A2. So super keys will be the summation of 2 raised power n minus 1. These are the super keys with respect to A1 plus 2 raised power n minus 1. These are the super keys with A2. But you have counted this keys twice. You have counted this super keys twice. So how many super keys are there in which both A1 and A2 are present? Sir, 2 raised power n minus 2 super keys are there in which both A1 and A2 are present. So it should be subtracted from the total number. Yes or no? Yes. So what will it be? So this will become, I can write it as 2 raised power 2 into 2 raised power n minus 2. Yes, sir. I can write it as 2 into 2 raised power n minus 2. Right, sir? You can write it as 1 into 2 raised power n minus 2. So this will eventually become 3 times 2 raised power n minus 2. This will eventually become 3 times 2 raised power n minus 2. Now the idea is, sir, the methods of calculating the super key may be different. So there is just one approach. There is just one approach. I can give you the another one. Sir, these are the two attributes. If either of A1 or A2 is present, let's try to understand. If either of A1 or A2 is present in the set, then it will be a super key. If either of A1 or A2 is present in the set, then it will be a super key. So how many subsets are possible of n elements? So total number of subsets possible out of n elements are 2 raised power n. Total number of subsets possible out of n element are 2 raised power n. Out of those 2 raised power n elements, there are subsets in which neither A1 is present nor A2 is present. So how many are the subsets in which neither A1 is present nor A2 is present? Can you give me the answer for this question? The total number of subsets of n element are 2 raised power n. Now, how many subsets will be there out of those 2 raised power n subsets in which neither A1 is present nor A2 is present? So let's look at the idea. Sir, A1, A2, A3, A4, A5 up to AN. Sir, there are two ways of choosing this. Either you will choose A1 or you will leave A1. So there is only one way of leaving this, and there is only one way of leaving A2. So this is the idea in which both A1 and A2 are left. Then apart, once you have left A1, you have left A2, you can choose any combination of any two. So you can choose A3, you can choose or leave A3, you can choose or leave A4, you can choose or leave A5, and so on. You can choose or leave AN. So how many total ways? So these are 2 raised power n minus 2 subsets. There are exactly 2 raised power n minus 2 subsets in which neither A1 is present nor A2 is present. Right? So out of total number of subsets of an element, if I subtract the number of subsets in which neither A1 is present nor A2 is present, then I'll get the subsets in which either A1 or A2 is present. I'll get the subsets in which either A1 or A2 is present. So in a subset, if either A1 or A2 is present, then it will be a super key. In a subset, if either A1 or A2 is present, then it will be a super key. Then how many are such? So this is 4 times 2 raised power n minus 2. This is 1 times 2 raised power n minus 2. This will also be 3 times 2 raised power n 3 times 2 raised power n minus 2. Yes, sir. This is also the same thing. See, similar thing can be done in a different way. Okay. let's see. So let's use the same combination. Let's use the same method which I have described just now. What else can be done along with this method? Sir, the total number of elements are n. Total number of elements are n. So what are the possibilities to make a super key? What are the possibilities to make a super key with A1 or A2? So, sir, the idea is, so what is the idea, sir? So what is the idea? So the idea is something like this, that these are the elements. So either A1 is present and A2 is not present, then with any combination of n minus 2 element, it will be a super key. A1 is not present and A2 is present, then any combination of remaining n minus 2 element will give you the super key. If both A1 as well as A2 are present, then also any combination of remaining n minus 2 element will give you the number of super keys. So how many such sets are there in which A1 is present, A2 is not present, and any combination of remaining n minus 2? So there will be exactly 2 raised power n minus 2 such patterns, because one, you can choose A1 only in one way and you can leave O2 only in one way, and for the remaining n minus 2 elements, you have 2 raised power n minus 2 choices. Therefore, 1 into 1 into 2 raised power n minus 2, that will be 2 raised power n minus 2. Now, in how many ways you can leave A1 and choose A2? So you can leave A1 only in one way and you can choose A2 only in one way, multiply by 1. And for the remaining n minus 2 elements, you have 2 raised power n minus 2 choices, then again 2 raised power n minus 2. Now, in how many ways you can choose A1 as well as A2? So you can choose A1 as well as A2 only in one way, and for remaining n minus 2 element, you will have 2 raised power n minus 2 choices. So a super key will be composed of a scene when A1 is present and A2 is not present, or, so whenever you say or, you perform the addition, or a super key will be composed when A1 is not present and A2 is present. Yes. Or a super key will be formed when both A1 and A2 are present. So just add this 3, you will eventually get 3 into 2 raised power n minus 2. So for doing the same thing, you have multiple ways. For doing the same thing, you have multiple ways. You will reach at the same solution if your approach is correct. I hope there is nothing wrong with this, right? So that's one. Now, I ask you one more question. Okay, fourth, how many super keys are possible if the candidate keys are, if there are multiple candidate keys, one is A1, A2 and A3, A4. A1, A2 and A3, A4. How many such super keys are there in which A1, A2 is one candidate key, A3, A4 is another candidate key? Fourth, the candidate keys, if the candidate keys are A1, A2 and A3, A4. So this is one candidate key, A1, A2 together form one candidate key, A3, A4 together form another candidate key. So I'm asking, how many super keys will be there in this situation? You try calculating this. See, mathematics is something that if you follow, see, let's try to understand. You may say, sir, that the concepts of set are not that important, right? So that's the idea, that discrete mathematics plays an important role in the computer science engineering. If you do not understand the concept of discrete mathematics properly, that at various places you may find it difficult to solve the numerical problem. So please, if you are sincere for GATE exam, then I generally tell students to start with discrete mathematics. So that's a very basic course you all have studied in your second semester itself. But why I have started with DBMS is that most of the student will find it difficult to understand DBMS. But so there's another way, just study sets. So I have discussed the concept of sets on the application, then only I have started with the DBMS, because I know the requirement of sets will be there when we will try to understand the concept of DBMS. So if you are trying to learn from me, then please understand that if you are following all the lectures of mine, whether they are on the application or they are on the YouTube, then they are all connected. Many of you may not understand this thing, that what is actually happening. But someone who has already understood the concept of principle of inclusion exclusion in the discrete mathematics class will know this thing, that what is actually happening. So let's see. So what will be the answer? Sir, how many super keys will be? So do it on the another side. How many super keys will be there in which A1 and A2 are present? Sir, 2 must be present. For remaining n minus 2 element, you will have 2 raised power n minus 2 choices. Now, how many super keys will be there in which A3 and A4 are present? Sir, A3 and A4 should be present. For remaining n minus 2, you will have 2 raised power n minus 2 choices. Now, how many are there in which A1, A2, A3 and A4 all are present? So all 4 are present. For remaining n minus 4, you will have 2 raised power n minus 4 choices. Yes or no? So what will be the overall solution? So the solution will be 2 raised power n minus 2 plus 2 raised power n minus 2 minus 2 raised power n minus 4. So this will come out as 4 times 2 raised power n minus 4, 4 times 2 raised power n minus 4, 8 times minus 1 time. So the answer will be 7 times 2 raised power n minus 4. Yes or no? 7 times 2 raised power n minus 4. Clear, sir? Sir, can you also explain, sorry. Can you also explain this in the another way? So see, if it is a concept, it can be applied everywhere. So let's try to understand that if you have A1, A2, A3, A4, then you only need to worry about A1, A2, A3, A4. For remaining A5 to AN, these are n minus 4 elements. These are n minus 4 elements. Right, sir? So either both A1 and A2 should be present, or both A3 or A4 should be present. Tell me, if there is a set in which A1 is present and A3 is present, then will it form a super key? Will it form a super key? No, sir. All the attributes of at least one candidate should be present. All the attributes of at least one candidate key should be present. So either both A1, A2 should be present, or both A3, A4 should be present. But it is not that one attribute of one candidate key and another attribute of another candidate key. No. Sir, what are the possibilities? So let's look at this. What are the possibilities, sir? Sir, the possibility is that both A1 and A2 are present, but A3 and A4 both of them are present. Both A1 and A2 are present. Apart from that, A3 is present, but A4 is not present. A1 and A2 are present, but for this too, A3 is not present, but A4 is present. Similarly, A1 and A2 are present, and A3 and A4 are also present. Apart from that, A3 and A4 are present, but A1 and A2 are not present. A3 and A4 are present. A1 is present, but A2 is not present. A3 and A4 are present. A1 is not present, but A2 is present. Right? When you say A1, A3 and A4 are present, as well as A1 and A2 are present, then you have already counted this. You have already counted this. Therefore, you don't need to count this. Sir, for remaining n minus 4, this will be 2 raised power n minus 4. For remaining n minus 4, 2 raised power n minus 4. For remaining n minus 4, 2 raised power n minus 4. For remaining n minus 4, 2 raised power n minus 4. For remaining n minus 4, 2 raised power n minus 4. For remaining n minus 4, 2 raised power n minus 4. And in the end, 2 raised power n minus 4. Total, how many times 2 raised power n minus 4? So 7 times 2 raised power n minus 4. So the number of such super keys will be 7 times 2 raised power n minus 4. I hope you have understood the concept that how you need to calculate the super key. Now I am giving you some homework problem. You guys can solve those problems and can provide the answer in the comment box. Clear? You guys can solve the problem related to number of super keys and can provide the answer in the comment box, so that I'll be able to check that how many of you have understood the concept. Clear है भैया? Okay, so let's take some homework problem then. So the fifth problem, these are your homework. What The candidate keys are A1 and A2 and A3. Just for the sake of understanding that whether you have understood the concept or not, the candidate keys are A1, A2 and A2, A3. There's a difference. In this example, A1, A2 are A1, A2 and A3, A4 are two disjoint sets. But in this case, A1, A2 is one set, A2, A3 is one set. There's something common between these two. The candidate keys are A1, A2 and A3. So there are three candidate keys this time. Got the idea? So just try calculating these three questions. Have you understood the concept of different types of keys? Now you will say, sir, there are some other types of keys which we have heard of. Foreign key. Yes, there is a key, foreign key. That foreign key concept which we will understand when we will actually understand the concept of relationship. That, okay, there is one table student, another table course. Now, the students are enrolled in the course. Then this table enrolled, you will have SIDs and CIDs. So, in this table enrolled, SID will be pointing to the primary key of the table student. Therefore, SID in the enroll will be a foreign key, and this course ID in the table enroll is actually pointing to the primary key of the table course. Therefore, this CID in the table enroll is foreign key with respect to table course. So that thing we'll understand when we will understand the concept of relationship in the more detail. But at this point of time, I don't want to burden you guys with some unnecessary definitions which may not make sense at this point of time. So whatever I have discussed in today's session, I hope these are just the terminologies, but I hope that you have understood all those terminologies in a proper way. You have understood that when null values are allowed, when null values are not allowed, what do I mean by super key, how do you obtain the super key from candidate key, what do I mean by the prime attribute, what do I mean by non-prime attributes, what is a simple candidate key, what do I mean by compound or composite candidate key. The same time, attribute and attribute sets. When I say attribute, so A1 is a attribute. So A1 is a attribute. A2, A3 is a attribute set. So attribute set. So attribute set may also be form of a single attribute or maybe a combination of multiple attributes. So that's what you need to understand, that all this information must be crystal clear in your mind. When I have given the definition, I did not say the attribute which has the unique value. I said the attribute set. The set of attributes. So it can be the combination of multiple attributes which is uniquely identifying the tuples of the relation. Same is the definition with the candidate key. The minimal set of attributes, a set of attributes or a single attribute is also a set. So attributes, the set of attributes may be composed of a single attribute or may be composed of multiple attributes. It's a different thing. But if the set of attribute is minimal and it can identify all the tuples, then it will be a candidate key. If it is not minimal, then it will be a key but not a candidate key. Now, every candidate key is a super key because a minimal set can also differentiate. So this is the definition of super key. See, just a set of attribute which can uniquely identify the tuples. It may or may not be minimal. So if it is minimal, it is a candidate key, but it is also a super key. If it is not minimal, then it is just a super key but not a candidate key. So these are the basic terms which make people confused, that they are not understanding the concept of database management system. No, the DBMS is damn easy. So these are just some things which I have discussed. How do you define a super key attribute set? You need to have all the attributes of at least one candidate key. Then you can have 0 or more attributes from the remaining attributes of the relation. This is it. Right? So that's the idea. That thing. Just follow the course and I assure you that you will learn everything. You will be able to solve each and every PYQ of database management system. That's my guarantee. Right? Just follow the flow, if you will try to flow in a different direction or dimension, I may not be able to guarantee anything. But if you are following this lectures in a live manner, and so that if any doubt occur in your mind, then you will be able to ask. If you are following this series live, then it will be more beneficial. Yeah, when you watch it live, sometimes it may be time consuming, that you know that I already know this concept, so you can fast forward when you are playing a recorded session. But then if you don't know something, and if a doubt occur, then I'll not be there to explain it. Okay, so anyway, this is it. Thank you very much. Already I've extended the session for a very long time. So okay guys, so for some reason I could not take the today's class at the application, therefore tomorrow there will be 2 classes at the application. One will be at 8 a.m. and another will be at 9 a.m. In the first session, we'll discuss the rules of inference, which I was supposed to discuss in the today's session, but I could not initiate the class. But tomorrow we will have 2 classes and we will complete both these topics, rules of inference and terminologies of predicate logic. So along with the rules of inference, we will also see how to solve the questions related to propositional logic. So that will be all guys. Thank you very much. If you like the video, then please hit the like button. If you are new to the channel, then kindly subscribe for the channel and press the bell icon so that you will get the notification about our upcoming videos. Thank you very much. See you tomorrow. Good night. Bye bye.